This episode of This Agile Life has been brought to you by BrilliantAgile.com, providing Agile and Scrum training, consultancy, and personnel.
BrilliantAgile.com. Done right, it's brilliant.
Released on Sunday, April 27th, 2014, in St. Louis, Missouri, This Agile Life, Episode 46, Rough Sketch of Your Mom. Our exclusive sponsor tonight is CodeShip. CodeShip is continuous deployment made simple. Try CodeShip free. Setup only takes 3 minutes at codeship.io.
The software industry transforms more and more every day. Agile methods are quickly replacing traditional ones. The question is, are you agile enough? This podcast is devoted to agile and lean software development. Time to welcome your agile coaches on This Agile Life.
Hello, everyone. I'm the host of This Agile Life, John Sextro. Joining me today are my co-hosts, Nate Mackey. Welcome back, Nate.
Thanks. I'm so glad to be here.
It's been a while. We've missed you, but we're glad to have you here tonight with us.
Yeah, absolutely.
Also here tonight, he missed the last show, Amos King.
I will try never to miss it again, John.
Are you losing your voice?
Do what?
Are you losing your voice?
I've had a lot of allergies lately. Here in the Midwest, it's full of nothing but pollen, so...
And other things, but mostly pollen. All right, also joining us tonight, Jason Tice.
Hi, John. Yes, the Midwest Amos is full of improvements.
Oh, God.
Guys, we have a special guest with us tonight. We have Llewellyn Falco. Hey, Llewellyn.
Hello.
Llewellyn learned to jump horses in 7th grade while living in France. Back in States while studying drafting in high school, he started fire eating, sleight of hand magic, and once rode a unicycle 6 miles. I can't even ride a bicycle 6 miles. After learning to juggle torches, he joined an aerobatics group in college where he specialized on the trampoline and walking a slack rope.
Acrobatics, John. Acrobatics.
What did I say?
Aerobatics.
Same thing to me.
I think aerobatics would be better. I should try that out.
You should change it to aerobatics.
Hey, John. You did above the trampoline, right?
Hey, John, you just won a constellation prize.
Thanks, Dice. Let me get through this. Llewellyn can calculate the cube root of any perfect cube under 1 million in his head, as well as pick a standard lock. I can pick a standard lock. He can rollerblade down a flight of stairs backwards. Later, he has learned to play the doumbek, a type of drum. I hope I said that right.
Absolutely. To
accompany a belly dancing girlfriend. Llewellyn studied Tai Chi for 2 years, can throw a knife at 20 feet, and a playing card at 50. He's taught swing dancing and loves to salsa. He's also an accomplished speed chess player. In the last year, he's been scuba diving over 20 times, become a guitar hero, and broke his personal record of paddleballing over 200 times. Llewellyn attributes his success to the large amount of caffeine he's consumed and enjoys computer programming in his spare time. Llewellyn, once again, welcome to This Agile Life.
Oh, it's great to be here.
We are quite pleased to have a person with such a storied resume on our show with us tonight.
This is fantastic. It sounds like a speed dating card.
That would be a great speed dating card, but I think you only get like 5 minutes for the whole thing.
Yeah, there'd be nowhere to go. You'd be like, well, I don't know where to start with you. It's too much for speed dating. Tonight with our speed dating episode, as it were, we're going to talk about approval tests. And Llewellyn is kind of one of the pioneers in the space of approval tests. So, Llewellyn, can you give us an introduction to approval tests?
Yeah. So approval test is a specific framework for the general concept of approval testing, which is with regular testing, we try to declare everything that we're going to expect. So you do something like, say, add 3 plus 4, and then you declare your result 7. And that works really, really good for simple things. But when things start to get more complex, it's much harder to declare something than it is to recognize that you've gotten the right result. And that's where approval test comes in. Approval test sort of allows us to use our human brain, our sort of biological intelligence that we have that's really, really robust to be able to say, yeah, that's correct. Even if we can't exactly say why, And then we can capture that as part of our automated testing so it continues to do it. Does that make sense? Or do you like an example?
Guys, what do you think? Makes sense?
I think so, but an example might be good to have anyway.
So let's start with just this idea of recognizing versus defining. So let's say that you're having a friend go to the airport to pick up your mom. That'd be something like, you know what your mom looks like, right? I mean, you've lived with her your whole life, or not your whole life, hopefully. But I mean, you grew up with her, you know what she looks like. It'd be really easy to recognize her at an airport.
Now, wait a second. Am I sending Amos to the airport to pick up my mom?
You're sending Amos to the airport.
I'm not sure I'm okay with that.
But imagine if you had to describe her, how long her hair is, what color her hair is, what color her eyes are, how much she weighs, how tall she is. Really quickly, it just becomes really hard to do. And in fact, some of those details might, even for your own mother, you might not know, how tall is she? So it's much easier to recognize her than it is to declare the whole thing. And the same thing is going to be the case, say, if you have a large XML file. It might be much easier to look at that and see that it's right rather than create it yourself. Or a photograph. Imagine if you had to create a photo not using Photoshop, but by saying the color of every single pixel and what it had to be. And so a lot of times the way that we do a unit test can feel like you have to declare each pixel and you never get to see the whole picture and the bigger picture.
That's a great explanation of it.
Wait, John, what does your mom look like?
Kind of like me. Can I put that in the approval test?
I am not picking her up at the airport.
Can I put that in the approval test? Mom kind of looks like me.
So you can't say that. What you could do, and this is so very weird, the way that approval test works, you could actually create the test and put a picture of yourself. And then when he goes to the airport, he can kind of use that to look until he actually finds your mom and say, that's close enough that I can recognize that it's your mom. And then he can move that picture over of your actual mom. So you can do the sort of close enough aspect. And we see that happen a lot. In fact, for stuff like UI, we'll see approval tests where the initial thing is just a hand sketch. And that's, it's something people might do on a whiteboard and they'll just sort of snap a photo of it. And then that will be the guide as you're actually programming the UI until it's there. I'm not saying that you're a rough sketch of your mom, but I think the idea is there.
That might be the show title.
I think so.
So how would I use this? I mean, functionally, how would I take this rough sketch of a user interface and then build towards the actual user interface based on that rough sketch and using the approval testing framework?
So I think what I should do is sort of take you through a little of the history of how we get there. And then what I say might have a little more context around it. So when I first got started in unit testing, we just started with primitives like everyone else did, right? These numbers are these numbers, or these very small strings, or these, brown is brown. But what happened is we started to use lists. And when we were making these arrays of objects, it became really cumbersome to type in the whole array again of what we expected. And so we did this shortcut where we'd say array.toString and we'd get the sort of textual representation and I would just copy that in. And so I had these asserts equals and then this string that I would copy in once I saw that was correct to the array.toString. And that worked really well. But then that string started to get a bit bigger and a little more unwieldy. I'm working in Java at the time and Java doesn't handle big strings very well. So quickly we started to say, okay, well, if we have a big string, let's put it in a separate file. And so now I would sort of say, assert that the array.toString is equal to the contents of this file. And that worked really well for a while because I didn't have to have the string inside the code. But then what I had to start doing is come up with names for all these different files. And that started to get annoying. And so we started to use this convention of just the file name would be the method name of the test. And so that worked pretty well. But then I got annoyed that I had to keep doing that. And if I refactored, so it was just annoying. And so I said, I can write a little block of code that just automatically generates the file name based on the method that it's in. And so we did that. And that worked really well. But now I'm seeing over and over, I'm saying, create this generator of the file name and put it in. So we just quickly wrap that up in a method as well. And then all I was saying was verify the array. And it figured out the file name for me, checked the contents of that file, made sure they're the same. And that worked really well for a while. But because this text kept getting bigger and bigger, now that it was in a separate file, it was easier for it to get bigger. when it would fail, sometimes you couldn't really tell what was wrong with the text, what had changed. When there's sort of like 20 lines of text, that gets a little bit rough. And so what we would do is we'd sort of save it off and open up a diff program to tell you what the difference is. And then quickly I got bored of that again. So you can see sort of the general progression here is my desire to be lazy is really sort of driving this whole thing.
That's what drives all good developers.
When it failed, it just automatically opened up a diff tool for us so we could see it more robust. And that's sort of the whole genesis of it. And so then, because it's opening up this diff tool anyways, the first time you run it, the other side is empty and you just move it over. But now if you think of the sketch of your mom or the picture of you instead of the mom, we'd run it. It would come up empty on both sides because we haven't yet figured out how to pick up your mother at the airport. And so we'd put your picture in and then we'd go to the airport until we find the picture that we think is sort of close enough. And you'd see it side by side and you say, yeah, that's what I want. So that's the human part of your brain making a very sophisticated understanding of intelligence to say these two people are related, right? Like that's something people can do, but it's amazing that we can do that. If you ever tried to make a program for that, just impossible, or not impossible, but very, very hard, above my abilities. And so now that you see that, you just copy the photo over and you say, okay, I got it working. Let's keep it working. Does that make sense?
It does. I'm actually a little sorry I ever brought up the mom at the airport thing, but
we all are.
It seems like it would be really good for like testing reports, right?
Oh,
testing
it's fantastic
reports
for testing reports.
It's a horrible experience.
Yeah.
So I think I would be really happy with it in that case.
GUIs, reports, things that are visual. I find that without some kind of mechanism like this, they don't get tested. A lot of times they're just getting neglected, which is unfortunate because those visual places, that's what a lot of users think our entire program is. They don't understand that there is actual real work that generates that report. They just see the pictures. That's one of the reasons you bring a good graphic artist and your users go crazy.
This is a problem I remember us working on back when you had to do more SQL wrangling when you were trying to get a program to work. And I remember J.B. Rainsberger had written a book on unit testing and specifically talked about a strategy you could use for this kind of testing where instead of actually running a query with your test and hitting a database, you would instead in advance generate what you thought the query should be using a database querying tool. Go figure out what your select statement would be. And then take that and make that the gold master. This is what I want to accomplish. So whatever my program does, I want it to end up executing this query. And then you replace in Java, you'd replace your JDBC driver with something that would take the input from your application and convert it into that query. Say, this is what I would have run against the database. And something like this would have been perfect in that case because you're looking at, here's what I want my query to be. And then you look at the output and you can tell whether it's matching yet or not instead of having to, like you said, when it failed, go, pull it up in a diff editor or something and figure it out line by line to see what the difference was. That would make a lot of sense.
Yeah, we actually take that to one level higher than that, which is we have a concept called the iExecutable query. And with the iExecutable query, we say in that process, the SQL is actually more important than the result. That we trust our database knows how to execute SQL.
Exactly.
And so we have that concept, and there's one other concept that's really important, which is when things are failing, you care about them more than when they're passing. If you think about it, let's say you take your car into the shop and the mechanic comes back and he's like, your engine's okay, your wheels are okay, your steering's okay, your transmission is shot. You don't go to him and say, tell me more about the wheels, right? You want to know about the transmission. The stuff that works is fine. I don't care about that. It's the stuff that's not working that I want more information about. And so iExecutable tests really harness on this issue of granularity and feedback. And so what they do is when you run them, so first of all, approval tests always fail the first time you run them because until you say as a human, this is okay, they cannot pass. But you run them and it generates that SQL and then it fails because the SQL doesn't match the expectation because you have no expectation. And then on failure, it says, okay, let me take your SQL to the database and get the result. So you see the SQL and you see the result, but you only verify the SQL. You do not verify the result. And so the next time, if the SQL is the same, it doesn't even go to the database. Test is like, I got the SQL, I'm good. So the database could actually be down and it would pass, which makes these tests very, very quick.
Yeah.
But if they fail in the future, it's going to take both the old SQL and the new SQL to the current database. It's going to execute both of them. And it doesn't matter if they give the same results or not. It will fail either way, but it will show you the results of the old SQL in the current database and the results of the new SQL in the current database. And what that means is you don't have to set up your database. So if you're using an ORM, these tests become one line of code. And they run super fast because they don't even hit the database. When they're passing, I can run thousands of them in fractions of a second. And if they don't pass, they take longer, of course, because they go against the database. But it tends to be the case that, only one is not passing at a time.
Now, so just to poke at this a little bit here, it sounds like then you're encouraged to fix your tests after you've written your code. Is that the case, or?
Sort of. I'm going to break it into all the parts of unit testing, because it's not, the test doesn't pass until after you've written your code, but you're still writing your test first, and that's really important. Okay, so there's 4 big things that unit tests give you. The first is specification. A little example of this. I was working with a couple different contractors, and we were doing this thing for an email site, sort of filtered out emails that were inappropriate and stuff like that. And so one guy, he was going to create this thing that gave us sort of an XML of the different way that, different features of the emails. And when we were done, everyone was nodding and they're in agreement, and they're like, yeah, that works. Send us that XML. And I sort of said, maybe we could just write on the whiteboard an example of what that XML would look like. And everyone's like, no, we know that. We got it. We're all good. But I think just to humor me, or maybe because I'm really stubborn sometimes, they decided to write an example out. And as soon as they started to write it out, they're like, no, that's not how the date should work. That's, there was this illusion that we were all in agreement. But as soon as we started to get in a specific example, all of a sudden that disagreement came out. And eventually we were in agreement before we left. But what chance would I have had as a programmer of making these people happy when they did not yet agree on what it is we were going to write? And so this isn't even at this point, I'm not even writing an automated unit test. I'm really only doing coding by example. But that example, that specification, gives me sort of the lines in which I can color in. And that's really valuable to me. Once I have that example, I can turn it into code and I can run it, or I can just run it, right? I could manually run it. And I see a lot of programmers, especially the PHP programmers, they write a little code, they open up the browser, they write a little code, they open up the browser. They know what to click to give they're sort of doing this manual testing, but to get the feedback of what's going on. That's really valuable when you're programming, because programming is complex and you need to be able to get that feedback to create stuff. And there's even some good theories and studies that show that feedback actually allows us to create stuff. It doesn't just make things nice, it is actually empowering. All right, so that feedback sparks your creativity, sparks your brain. So again, we're still not really to automated unit tests at this point. We have an example that we're trying out by hand. But if you take that example and you codify it so it is an automated unit test, now we can do 2 things. One, we turn up the speed of that feedback. And that's important for a couple reasons. One, there's a real ROI that pays off, right? If it takes me 15 seconds to open up a web browser and click 3 things, and it takes me 2 minutes to write that unit test that does it and opens up the result for me, right? If I do that 8 or 9 times, I'm already ahead in the amount of time I will spend. So it pays off pretty nicely. But the other thing is the amount of time it takes you to do something. Let's say you're working on a phone and it takes you 2 minutes to deploy. Well, then you're not going to deploy to that phone every 30 seconds.
That's right.
Because your entire day at that point is just seeing it deploy. You're not even going to do every 2 minutes. You're going to wait every 8 minutes or every 10 minutes.
Yep.
And 10 minutes is a large chunk. And when these things get bigger, your chunks get bigger. And then we make a lot of mistakes in those chunks when you're taking big steps. My mother used to say, inch by inch, it's a cinch, yard by yard makes it hard. When you're programming in 30-minute or 40-minute chunks, you're making a lot of mistakes in there. So turning up the feedback allows us to work a lot better that way. And that's just automating it. But then you add that one extra line to do automated validation, And now you get regression, which is something that you almost never get if you don't do automated tests, which is it works today. And guess what? It works tomorrow. That is such an important part of programming that, all of us have experience with bugs resurfacing. And the only way you get out of that is a large set of tests. And practically in today's world, if you want a large set of tests, those are going to be automated because you just can't hire the amount of people needed to do that level of testing at that level of speed. It's just an unfathomable amount of, if you look at stuff like the Ruby test suite, it's 22,000 tests or something like that. Think about hiring people to run that multiple times a day by hand. It's just, you can't do that. It's not feasible. And then finally, there's granularity. And granularity is, if you think of these in time, spec is before you know what you want to write. Feedback is when you know what you want to write, but you haven't done it yet. Regression is, okay, I've got it working, let it keep going. And then granularity is, it used to work, but now it doesn't. And that's sort of like feedback in some ways, right? Because, the numbers can help you, the asserts can help you, but there's things that will help you that aren't related. So for example, the name of your test can help you understand what went wrong, right? So when the array handles empty values goes wrong, you don't even have to look at the code at that point. The name of the test is telling you what's wrong. And also there's temporal granularity, which is, if I change one line of code in my test break, then I know it's that one line of code, regardless of what my tests tell me. And I think continuous integration is all about that temporal granularity. When I was on teams of 6 people, which isn't a lot of people on a team, and we would do a nightly build and something broke, there was a lot of finger pointing. It must be your code. Oh, it had to be your code. You changed that, but you changed that.
Right.
When you go to CI, then you know exactly who broke the code. Right, because you have that temporal granularity. It worked before Llewellyn checked it in, and it didn't work after. Guess whose fault it is? That granularity is really, really important, really, really valuable.
The granularity is so important. I think especially with UI testing, it seems so hard with tools. Typical tools that I've worked with, you might have a UI test that fails. But if you don't have a way to assess why did it fail, did the screen not paint in time? Was the value I was expecting not there when if you have something that you can physically inspect after the test has run, like you've taken a screenshot or whatever the thing is, that granularity to show you exactly what is wrong is key. Otherwise, you then spend 15 minutes rerunning the test manually, trying to figure out where is it failing, what is failing, right? And granularity is so important here.
And this is where tools just become so beautiful because, just seeing the old by the new side by side, that can be really helpful. It can be obvious what's changed. But sometimes side by side, it's not obvious. And so one of the things the tools will do is they'll overlap them and then they'll do subtractive diffs. So it will show you exactly, this cluster of pixels is the thing that changed. And this is something computers are really, really good at. And if you've ever tried to do a jigsaw puzzle, people are not all that good at. Colors that look the same can look different to us, or little details can get lost in the field. But computers are remarkably disciplined. They do the same thing over and over and never complain. It's quite wonderful.
You mentioned earlier that this is really similar to how when you test a picture, you wouldn't want to test every single pixel. Does approval tests work for testing things like that, things that are visual, things that are graphical?
Absolutely. Approval test is actually very, very dumb, which makes it very, very powerful. Anything that you can put into a file, approval test can verify it's the same file, right? It doesn't understand what a pixel is or anything like that. But that means if I can create that PNG, twice, it works. If I can create a PDF, twice, it works. If I can create a WAV file or an MP3 twice, it works. If I can create a text file, twice, it works. And basically that just becomes really, really useful. The one place it's sometimes annoying is line endings. Can't tell you how much of my life gets wasted on line endings.
We've all wasted a few hours on that. Looking at the approvaltest.sourceforge.net, the workflow that you've got out there, Llewellyn, there's an example here where you're showing candy bar and soda and a price, and you run it once, right? And then it shows you something, and it says, is this the result you expected? And then you tell it yes or no. I guess you're telling it yes predominantly, but
Oh, well, that's very optimistic.
Yeah.
My coding style is not good enough to say yes predominantly.
Well, I guess for the sake
it's surprising how often I do the wrong thing before I do the right thing.
Yeah, but you make a judgment and you're eventually going to
Absolutely.
tell it, this is the thing I want you to compare against. And it takes care of saving that and then doing the evaluation for you the next time. Every time you do that evaluation, does it re-prompt? Is this right, or do you have to go back and tell it somehow I want to reset what the expectation is?
So as long as it matches the expectation, it doesn't bother you.
Okay.
Same as, when your mechanic's like your wheels are fine. It just does its own thing automatically, passively. The only time it asks for your attention is when things are different, which is, I guess, the same in all things, right? Like, even if you did like an assert, a lot of times you'll have that little extra piece of text that is the descriptor. It doesn't tell you the descriptor when it passes, right? In fact, a lot of frameworks, especially on the command line, it'll be like ... And then if it fails, it will give you information, right? So it won't even like tell you the tests that are running that are passing, because that's how little you care about stuff that works. But when it fails, then of course it's going to come up and re-prompt you and say, okay, I failed. Did I fail because I changed in a way you wanted me to change? Or did I fail because I changed in a way that you weren't expecting? Right? And it has no way of answering that. You have to answer that. But it will give you all the tools that, are possible to help you answer that as quickly and easily as possible.
And then do you have a way to run these approval tests on like a continuous integration rig where it will just simply fail and not prompt you?
Yes. Two things involved there. One, approval tests. So there's a whole bunch of testing frameworks out there, right? And they all have different advantages, but they all sort of ask you, like, monogamy is not the right word for testing framework, but it's like, choose me. Like, I am your testing framework and it's only me and nothing else. And that's because they sit on top. They are like the entry points to the way you run tests. Approval tests doesn't do that. It sits underneath your testing framework. So all the things that you normally do, it just works with approval tests. And that paradigm holds across languages. So if you're using approval tests in Node, you can use Jasmine, or you can use Amoka, yeah. If you're in Ruby, you can use RSpec, or you can use Cucumber. If you're in Java, you can use JUnit, well, actually Java is just really JUnit. But .NET, you have MS Test and NUnit and XUnit and MBUnit, and we don't care. We write hooks so that we can work with all these frameworks sitting underneath. And that means all the tools that you're used to, you get to still use them. And CI being another one of those tools.
So while we're on the topic of CI, I'd like to take a moment here in the show to thank our sponsor for tonight's episode. And our sponsor tonight is CodeShip. CodeShip is continuous deployment made simple. Guys, I just recently set up my current Node.js project on CodeShip, and it was easier to set up than I imagined it would be. Within a few minutes, my project was set up so that every new push to my repo triggered my test to run and then triggered my deployment to run. And boom, done, deployment made simple. I was worried that CodeShip wouldn't support Node.js, but fear not, CodeShip works with most major development languages and databases. CodeShip also integrates with just about every cloud service and hosting provider on the planet. And even if you're working on some exotic platform that they don't yet have an integration for, they have a script option to allow you to roll your own integration. If you need help getting started, the good people at CodeShip will be glad to help you. CodeShip has some of the nicest and most knowledgeable people you'll ever find, and they're so dedicated to testing and continuous deployment. They offer tons of helpful information on their blog at blog.codeship.io. Software development is hard enough. Let CodeShip make continuous deployment simple for you. Check them out today at codeship.io and tell them that This Agile Life sent you.
Yeah, I'm surprised how many shops I go to where continuous integration is still not there. It's such a big, important thing. You think it would have already permeated. And it has a good foothold. I think, of all the Agile practices, unit testing, if not TDD, is maybe the most adopted. And then after that, continuous integration. But there's still a significant portion of the world who does not have that. And it causes a lot of pain to not have it.
Yeah, that's amazing to me. And we had an episode we were talking about version 1 State of Agile survey. And I remember that being one of the topics, that you've got all these teams, even that are Agile, or at least calling themselves Agile, that are using continuous integration. And that's, it's funny, for us, that was like one of the first things that we adopted because it was just so great to have that in place.
Yeah.
I think it was like 70 or 80% were doing testing. So there was like 20% of people saying that their Agile teams aren't even testing.
Yeah,
like,
which is
wait
crazy.
a minute, what?
I mean, that's just crazy. What's weirder to me is the difference between the teams that are testing and the teams that aren't doing continuous integration. Like, I don't believe, I forget what the numbers were, but if it was 70% for testing, and just for example, I'm just making up a number right now, say it was 50%. I think there's 20% of the teams that are lying that they are testing, because in my experience, if you're not doing continuous integration, if you try running those tests, they do not pass.
Yeah. The last one I wrote passed when I wrote it, though.
Yes.
They seem to go hand in glove. If you've already taken the time to create a suite of tests, to create regression tests, to automate all of your testing, how much harder is it to get it to be continuously running and integrating and all of those things that go along with that? It's like you're right there, just finish it.
But we're too busy to improve, John. It might help us speed up later, but we're really too busy right now.
That is actually the hard way to do continuous integration. I mean, most of the time when I go into a shop and I turn on continuous integration, what I do is I write one test, assert true equals true, and then I turn on continuous integration, because it's really easy to get CI working with true equals true. And then they start adding tests, and then when a test fails, they're right in the moment to make it work on the CI server. If you write 100 tests and then like 15 of them fail, well, that's your weekend, and okay, well, let's just turn off CI and worry about it later.
Right.
So if, adding CI after you have a suite of unit tests, that is a much more difficult way to go than writing the CI first and then building a suite of unit tests.
Yeah, I think that's probably why. I think you're right that's why a lot of teams don't do it if they've already got an existing code. If it's not a greenfield project and they're just starting from what they have, just even getting a CI build up, they probably have one of the most painful things they do is probably deploy. They've never had CI.
So I do a lot of legacy code as well. And in fact, one of the reasons that I started adding some of the more robust parts of approval tests was because of problems I had with legacy code. And one of the hard lessons for me to learn when I would come to a client site was that nothing that I do, absolutely nothing that I do, makes any difference to the client whatsoever until it gets to production. And so the most important thing I have to focus on is how do I get an automated deploy, and how do I get it so I can deploy? Because I can fix 1 million bugs. If I can't ship it, doesn't stop a single customer from complaining, doesn't make anybody happy. And some hard lessons to that is sometimes when you sit back and say, how can I get this code to deploy? It means reverting in like a month or two of development, because the only way in some situations you can get something to deploy, because the testing hurdles and the bug hurdles, and you just can't undo what's occurred in the last 2 months. So the only way you can deploy sometimes is to take the exact same code that is currently in production and figure out how to redeploy it. And I've even had places where that's gone wrong, where we took the code that was supposed to be in production out of source control, compiled it, put it into production, and then stuff would break. And you realize, oh, the code that's in production is not even in source control. And now we're going to start talking about reverse compilation.
I've been in that similar situation, Llewellyn, and we've had to do things exactly like you talked about, like maybe even take parts of tests that, to Amos's point, tests that people did right, but because they haven't been continuously running those and doing continuous integration, they definitely don't work. And you have to kind of draw a line in the sand and say, well, just to get the continuous integration stuff rolling again, let's go ahead and turn some of this off. We won't run these for right now, but we'll put them kind of in our tech debt pile. And I know that that's horrible and terrible. You have to put time constraints around it and say, yeah, we're going to go back and make sure we turn these things back on and fix them. But like you said, you could blow a weekend or a week even trying to get those things running again. And just the fact of getting the continuous integration, the continuous building, continuous deploying, continuous testing going again, it's worth making some of those concessions to do that.
Absolutely, because you'll spend more time trying to save that month. You'll spend multiple months trying to save that month's worth of work.
And I find a lot of clients that even say that they have automated deployment. They have partially automated deployment. Like, we run this thing and it puts the code out on the box. Like if you're doing a website. But then we go out there and there's like 8 other scripts that we have to run every time we deploy by hand in a certain order. And it's all like overly complicated. So I think it's really important that when you get out there and you're starting to automate, like make it really a push button, one thing that you hit and you're done.
Absolutely. One button is sort of the limit, I think.
Jason, you wanted to get in here.
I've just been listening. And the thing that listening to Llewellyn that I really liked, because a lot of people ask, especially about CI, how do you get started? And so your simple advice, and this goes back to something we talked about on just the prior episode of how do you give a team a goal that is achievable. So you set up the CI box, put one test out there, make it pass. And then really for the team, that's a success. So they can say, hey, we got it working. We learned how to set up the CI box. It's there. And then if they have those tests, turn them on and say, oh, they all fail now. And then literally you actually have some metrics. You could say, every sprint going forward, we want to fix so many tests. And it might be a lot. It might be a really nasty goal, but at least it's a way to move forward and it's a way to measure progress. And so many times it's like, well, we don't know where to start improving. Well, at least here you have a system that gives you feedback, and over time you can measure progress towards improving.
So
I like that.
Go back to the idea of the walking skeleton that we talked about. Is that the walking skeleton of a CI? Is a true equals true?
Yeah, the simplest thing that can possibly work, kind of taken to an extreme. And it's also, we talk a little bit in Scrum about continuous improvement, but that does not get nearly enough focus. When you said do that little thing and make progress, we have a mantra in legacy code, which is it's not about good, it's about better. I think that's the secret of life.
And you mentioned, doing it sounded like some fire drills or some real life ops, Llewellyn, or real life challenges where, hey, prod's broken, go fix it. We don't know what the problem is. It's real life living the Phoenix Project by Gene Kim, if you've read the book, which is really great if you haven't, but I'm sure you have, but that's more for the listeners out there. But it's this idea of saying, okay, everything's broken or everything's messed up. Teams, especially if you're on a project with a big code base, have lots of problems. Pick something and just start doing it and start working towards improvement. Maybe you have metrics so you can see if you're really on the right track or not, but just the key thing is to start something, start small, and then measure the impacts, and then do that over and over again. And that's really how you can manage improvement over time.
And just ask how, what worked well and how can I do it better? One of the things Woody does that I just adore about him is, he always just sort of says, like, let's turn up the good. And, a lot of times we just focus on the negative, but there's a lot of power in just be a little bit better today than you were yesterday. And you know what? You look back and 5 years has flown by and all of a sudden you're awesome. And it's a good way to be.
Yeah, I'd like to go back to something you said earlier, Llewellyn, about the approval tests. You mentioned using that part of where they came from was trying to do legacy code development. It does seem like in legacy code, when the code tends to not be nicely taking advantage of object-oriented principles or whatever environment you're in and being nice and testable, that the ability to just test a large chunk of something or the large piece of output could be really useful and be a starting point to getting some tests in a system that may not have had them before.
Absolutely. And it's a technique that I use a lot. So there's a couple things at play. One is approval test sort of allows you to choose the scope. And I really want to point out that choosing the scope is important. But in legacy code, sometimes it's better, it's not good. And so taking an overly large scope can be a very powerful way of getting some kind of harness around the code. And we've actually done a couple things in approval tests specifically to write these tests that sometimes are horrifically big, but are unbelievably powerful. And so I'll give you an example where it's actually good from Yahtzee. So, Yahtzee is a kid's game with dice. You have these 5 dice, you roll them, you get different scores based on what's on the dice. We have an aspect of approval tests called combination approvals that allows you to write a test which would literally be sort of 2 lines of code. First, it would define a dice, right? So an array of numbers 1 through 6. Those are your options. And then you would say combination approvals, score Yahtzee, and score Yahtzee would take 5 numbers, 1 through 6. So then you would pass it that array 5 times. And combination approval starts and says, okay, my first possibility is 1, 1, 1, 1, 1, 1. And my next possibility is 1, 1, 1, 1, 2. And it just keeps doing that until it gets to 6, 6, 6, 6, 6, 6. And all of a sudden, you're looking at this output of 32,000 combinations and all the possible scores. And with legacy code, you don't even have to look at the output, because with legacy code, if you want to refactor it, the rule is whatever it did before you refactor it is what it should do after. So you can just sort of copy that over. And now I can refactor all day, and I know I haven't broken anything. Not even broken. I haven't changed anything. So I haven't fixed anything either. I haven't changed anything. And so however it worked is the way it still works. And the structure of the code is now cleaner and better and in a position that I can start to put tests that have more intention around it. And so I can do that with Yahtzee, but I also can do it where I say, okay, generate a customer and here's 5 possibilities for a name, 5 possibilities for an address, 5 possibilities for an age, and, like just spin those up and give me a combination of all those. Or I can go to the database and say, well, here's 20,000 customers, run them all through the report and generate me this just monstrous report and then do it. And even if that test only lasts for a day, and hopefully that test only lasts for a day, to be honest, like that's a bad test, but it gives me this freedom to start cleaning code. And a lot of times people who've lived in legacy code, they're like that abused puppy where it's, they're so scared to touch anything because they're afraid they're going to get hit. And their experience is borne out that way. Like it's not unintelligent behavior. They've been hit every time they touch something. But this is a new way where they can now be safe to touch stuff.
That's fantastic.
It's a great corollary, and it's so true. It's something that we see a lot with people that are just afraid to touch. You get those people on a project where they're like, oh my God, we can't touch that part of the code because nobody knows what it does. It's a bunch of black magic.
Yeah.
If you could just start to put some of these large grain tests, I guess, as it were, around these things so you could start to find those seams and those ways to start poking at it where you haven't broken anything. That's huge. That's very important.
Really huge.
Well, or going back to one thing Llewellyn mentioned earlier, I'm thinking using that actually into the reverse. Take the black box, put an approval test around it to capture its behavior, then go in and change something in the black box, watch the test fail, and try to learn from that. And
yes,
over time,
I've done that as well.
Yeah, no, and you're not going to release that, but you're going to say, okay, I went and I changed this because I thought it would do X, Y, and Z, and instead I got a different outcome. Use that to learn as a team so you can better support that production code base.
And sometimes you get the opposite, which is, I'm going to change this and, nothing broke. Apparently it's not working the way I think it does. But either way, that's a valuable thing. Poking it to learn, that's valuable.
And I think all too often, to what John said, developers, they're scared to go there because they're concerned about that feedback. And it's important to say, there's feedback that's triggered by learning, which is what we're talking about. And then there's negative feedback, which is, hey, we just don't want to break it. If you're in an environment and you feel that you have that, I think one of the takeaways I have from this discussion tonight, Llewellyn, is to definitely go check out approval tests and do some of this coarse grain testing to, effectively do some controlled experiments. And as a team or as a developer, challenge yourself to learn more about the parts of your code base that you're scared to go in and work with or that you have fear about.
Absolutely. Although I would say, don't go into parts of your code base that you don't have to go into anyways. All right. So sometimes we get people, and a lot of times, if you think about sizes of code bases, they're usually really, really huge. And so, if you touch something, there's always a risk. And so if you're going to touch it anyways, you're already assuming that risk. So clean as you go. And if you clean as you go, that's good enough. And maybe there's a section of your code that will stay messy for a long time, but hey, if you never have to go there, then it's good enough. And I think with programming, good enough is a very valuable mantra.
Llewellyn, how do you suggest that people how do you instruct them or coach them to getting started with approval tests? Where's the right place for people to begin?
So there's a couple things that are really important to make this whole thing happen. One, just with unit testing in general, as it was mentioned earlier, just try stuff and then improve. So try unit testing and pay attention to it. And the one step that seems to never be talked about in a unit test is go to the whiteboard, sketch out your scenario, and then write what you just did in English, and then write it in code. If you do that, we were given a bit of a disservice by calling ourselves programmers. If you think of yourself as automators, it's much more accurate to what we do in our day-to-day life. And so if you write something on the board and then write it in English, well, those are the steps that you need to automate. And then it really quickly becomes easy to write those tests. So if you do that, you're going to do good. There's a couple other things, though, that can make this whole process easier, especially with approval tests. So one is there's a whole bunch of YouTubes that I've put together on a whole bunch of YouTubes on YouTube. A whole bunch of videos on YouTube. Either way. So a whole bunch of videos on there that take you through different parts of it. And that's a really great resource. Go watch the video, see what you like. Another thing is people will be like, well, how do I test this? And we use approval tests to test approval tests. So if you go to the GitHub source code and look through our tests, like we have pretty good examples in there of how to test with approval tests. And then the last thing is, and this is a weird thing, but there's these things called koans. Are you guys familiar with the Ruby koans?
I am not.
So,
yeah, I am.
So Ruby koans are these beautiful things. The koan comes from the Buddhist word, which was these meditation puzzles you would think about to bring enlightenment. The one you've probably heard of is, what's the sound of one hand clapping? When EdgeCase brought it to the Ruby world, he turned it into these little unit tests that run but don't pass. And so they become these sort of like little, sort of like crossword puzzle-y kind of things where it's like, you need to fill in the blank to make it pass. It runs. It will fail, but you need to make it pass. And so we've written these for approval tests where, you know, you have these little unit tests that don't pass and you figure out how to make them pass. And, you know, they start very obvious, but they get more and more subtle and more complex. And by the time you're getting to the end, well, then you've just sort of explored and understood the whole system. And koans is a really useful way to go. The other thing I would suggest just so much is, if you haven't already listened to the episode about mobbing with Woody Zuhl, like go listen to that right after you finish this. But one huge advantage of working as a group is learning is so much more effective. Right? There's less frustration. There's more insights. It's more fun. There's a lot of research in the cognitive science world about the power of learning, you know, both in pairs and as a group. And a group is really, really a powerful way to learn.
Well, I think that's great advice. And Llewellyn, we really appreciate you introducing us to approval tests and walking us through the best ways to use it and how to get started with it. We'll be sure to include a link to those YouTubes on YouTube in our show notes. Guys, do you have any final questions or comments for Llewellyn about approval tests before we move on?
I have one statement I'd like to close with.
Sure.
So approval test is in a whole bunch of languages. I think we're in 9 languages right now. And the reason for that is because of the way that I do contributions. And so I want to just talk about that for a second. So if you hear this and you're like, hey, I want to try that out, and you go try it out, and it turns out that it's not doing what you want it to do, or there's a situation I haven't considered, the way that that normally is handled is you go to GitHub and you put an issue, which is fine. You can do that here too. And then maybe if you're, you know, if it's really bugging you, you download, you fork the code, you figure out how to get running. It takes a whole bunch of time. It's a real pain to do all that. And then like 3 or 4 hours later, if you figure out how to do it, you give a patch request, which then hopefully someone reads and accepts. That's not the way that we work with approval tests. So with approval tests, if you have a problem, send me a tweet. You can just use the hash approval test. It'll get to me within, 8 hours or so, and depending on your time zone. And then we'll do a Skype call. And you bring your knowledge of your problem, what's not working. I'll bring my knowledge of how approval tests work. We'll share a screen and work together. And, it's just an amazing thing to work that way. It will take less time than it will take you to download and figure out the intricacies of it. We'll have a solution that I will check immediately into master. And I get to see the beginner mindset of like how you are feeling that pain. And so a piece of that comes with me to the next time, and I will actually continue to write, sort of keeping you in mind in the future. And so it really benefits everybody. And believe me when I say, like, if it's a problem for you, there's probably another 50 people who are not complaining that it's also a problem with. We all really benefit from that collaboration.
That's the way I'm doing
I just wanted to put
all
that
my
out.
open source from now on.
I love it. It's a really powerful way.
That is awesome.
Well, that's a great approach, Llewellyn, and I hope you get a bunch of This Agile Life listeners that start to contribute to approval tests and take you up on that offer to tweet you out and then hook up on Skype to go over their requests and suggestions.
I'm looking forward to meeting all of you.
This week's hottest picks.
All right, Llewellyn, you're up first tonight with our picks.
So first pick is Nordstrom sunglass video. Go to YouTube, just put that in. It's a beautiful video from Jeremy Lightsmith, Gary Bernhardt, and the rest of the Nordstrom Innovation Labs team. They do a flash mob inside of a Nordstrom store for a week and build an iPad app live on the floor, and it just makes you feel glad to be a programmer. It's a very agile way of development. When you talk about on-site customer, nothing like, hey, here's the new app. Hand it to a customer. It's just a beautiful thing to see. So if you haven't seen it, I really like that. Another thing that I wanted to talk about was a TV show called Better Off Ted, which is, I think, a underrepresented TV show, but it's like a live action Dilbert. It's very brilliant. It speaks very strongly to the engineering mindset. It's really worth checking out. It's on Netflix if you have that.
I thought the commercials during that were real commercials at first.
I love it. Yeah. Technology, we make that. Cows. No, we don't make that. But we have made a sheep. Another thing that is really, really interesting and something I think is important if you're doing continuous integration, but even more so if you're doing continuous deployment, there's a wonderful TED Talk by Daniel Simons. And it talks about change blindness. And he has this part in the middle. The whole talk is really quite wonderful, but he has a part in the middle where he has one image and one thing is changing. But it's changing very slowly. And your job is to figure out the one thing on the image that's changing. What is it? And you can't do it. And, when they first hear about continuous, if you change things 12 times a day, my customers would rebel. Turns out if you do things 12 times a day, it's going to be really small and your customers won't rebel because they won't notice. In fact, they will go years and not even notice that anything has changed. You think about Facebook, how often it changes and changes and changes. You just have no idea. Because it's just little by little. Or when your kids are growing up and you look at pictures and you're like, oh my God, you've grown a lot. Or every time you visit your aunt, like any holiday, and she's like, you've gotten so big. But you don't notice it because every day you basically look the same. So I really like the change blindness.
I stopped getting taller a long time ago. My family still tells me I'm getting bigger.
Wait till they start telling you you're getting shorter. Age is a terrible thing. I have a podcast episode, a specific episode of a podcast the podcast is called Escape Pod, but the episode in question is called Subversion. And the premise of this, it's a science fiction story of people have gotten to the point that they can branch themselves. And they are at a counselor in merge conflict, trying to restore different branches of himself. And it is brilliant and funny.
Awesome.
I really hope that if that does happen, people learn Git.
Everybody gets their own copy of everyone else.
And then I'm going to give you a couple more quick ones. There is a product called Karma on the JavaScript testing framework. It serves your test by a node server. And so you can open from the command line, you can say run my test and it will serve it to all the web servers that connect, which means you can simultaneously test on Chrome, Safari, IE8, IE9, your actual iPhone and Android phone. Like any web browser you can point, it will go and test. It's an amazing way if you're doing JavaScript testing. I really, really like it. And then let's see, I'll do two more. This sounds so stupid, but 1Password, especially with the Heartbleed attacks that just happened. If you're not using a password manager, please use a password manager. And this sounds so stupid, but get your parents to use one too, and take their master password and put it in a place somewhere. There's this weird thing that's been happening lately where very sad and unfortunate, but friends who have had parents die. And trying to figure out what their online life is and closing out bank accounts and stuff is a nightmare. So some way of I think of it like having a trust or a will, have some way that people can close down your online life and figure that out. Keep your password safe. Do both at the same time. All right. And then I'm going to close with a movie called Touching the Void, which I think just a perfect example of sustainable pace. And that concept of just set your goals one day at a time and move in a very, don't do your big estimations. Don't do your project. Just take a little bit. But this one is played off by a person their comment is Everest is for wimps. So they go and they find this huge mountain in Peru that no one has ever climbed, and they climb it, and on the way down, they break their leg. And so the other guy's sort of lowering him down piece by piece in these huge winds, and he accidentally lowers him over a cliff. And so the guy can't stand up anymore, and he doesn't have enough rope, and the guy's holding on, and, hours go by, and he's sliding closer and closer to the cliff, and finally he's like, oh my God, I'm gonna die too, so he cuts the rope. And so a guy with a broken leg now falls down the mountain into a cave, and it's this documentary story about him sort of crawling out of this on a broken leg, going down a mountain. And it's really sort of a testament to what can occur if you don't think about the big picture and just think about how can I move another 20 feet. Wonderful movie, terrifying, but also just sort of brilliant.
Wow.
I think that's enough. I've already I've gone past my limit.
Just to be clear, there's no limit because Jason always complains about how I govern the number of picks on this show. But I don't know how we can even follow that up. I mean, that's such a great list of picks. I'll try, though. I'll go next.
I quit. I'm going home.
Yeah, exactly. My pick is so puny. It's just pales in comparison. But I'm too lazy to run my own tests, and I think most people probably are. I've started to set up all my projects to watch for changes and run all unit tests for me when it sees that things have changed. And I'll have a few links in the show notes for some of the tools out there that can do this, but I'd encourage everyone to try and do a similar thing and set up your projects so they watch for changes and then run the tests for you. Just another way to make sure you're running your tests often and that they're passing.
So which tool are you recommending for that?
Right now I'm using Jasmine for Node.js on my personal project. I noticed that there's also something called JUnit Flux for JUnit for Eclipse. And I know that there's other tools out there, but I don't know them all off the top of my head.
Ruby has Guard, which is pretty good, and you can use it just to watch your file system, so you don't have to have a specific language tool.
And that's what
I've
Jasmine...
used nCrunch on the .NET world, and I love that. And simple as it can be.
That's what Jasmine does too. It watches the file system as opposed to being like a plugin. So, all right, Amos, what are your picks tonight?
I kind of have two picks that are related to each other. Go out and build your own tools for fun. That's my pick. There's no link. Just when you find something to scratch your itch, don't go try to build for fun and profit. Build for fun. And, profit might follow later, but really just go out and enjoy yourself and be exciting. So building for fun, I'm not going to say what I'm building right now, but I found a library for Ruby called GLI that is for building command line interfaces, but command line suites. Like Git is a command line suite. Like you have Git fetch, Git pull. So you have all these like sub commands, and it makes it really easy to add switches and flags and documentation and get you started on the way. It even generates a project for you with the test suite ready to go for your CI box. We were talking about approval testing tonight, so I know that Katrina Owen had made some commits to Llewellyn's Ruby approval testing, and then she also has her own too. So I'll put links to both of those out there.
Absolutely. Katrina was the one who started the whole Ruby aspect of approvals with me. It was wonderful.
She's a pretty awesome person. I worked with her on Exorcism a little bit.
That's a great project as well.
Great, Amos. Thanks. And Nate, what's your pick tonight?
Yeah, I just have one pick. I will defer to Llewellyn's many awesome picks and just keep one of mine, which is, we have several projects running and we use Git almost exclusively across our projects. And we just have a Git server set up and we've got it tied into another system so that we can automate access. But, we've really been lusting after what GitHub offers. It's just that because we do contract work, many of our customers don't want us putting their code out on someone else's servers. So GitHub they're a great company and I don't deny them the ability to make money, but we just weren't able to afford the price that they wanted for their installed in-house version. However, there is an open source version of GitHub called GitLab that's pretty close. It's not everything, but it's pretty darn close. And so there's an open source version you can install locally and set up your own little GitHub. And also they have an enterprise version themselves, which is fairly reasonably priced that gives you some other capabilities and specifically stuff we need like integration with Active Directory and LDAP groups and that kind of thing. So I'm very excited about doing more with that in the future, but it looks like a really great product. I'd suggest people look at it.
Excellent.
I just want to piggyback on there. GitLab also has another product called GitLab CI. Yep. That you can integrate with your GitLab. It's a lot like Travis, if anybody knows what Travis is. So it's pretty nice that it'll listen to your commits and run stuff.
Nice add-on pick, Amos. Jason Tice, what's your picks tonight?
I have two, and actually the first is a missed pick from episode 45, our last sequential episode to this. We talked about metrics in that episode, and Craig Bushek was asking for guidance and help about what metrics to gather to get started. I mentioned that Scaled Agile has put together a rather comprehensive metrics abstract, which is a great thing to, if you're looking for ideas. There are lots of ideas in abstract, although if you're a single team, there's probably a few too many, but nonetheless, good information to review. And the second one that I've plugged before, and I'll plug again tonight, especially because Llewellyn's here, is the Agile Games 2014 conference. Llewellyn is one of our featured presenters at the conference, and he will be speaking really about doing a workshop entitled Learning by Doing and Puzzle Programming Konas, which we talked a little bit about tonight. And Llewellyn, I know your session is a hands-on keyboard session, so people should bring their laptop and be prepared to write some code and stuff. And something that I'm excited about for the conference is between yourself, Woody's going to be there with his mob programming. Yeah. We're going to have quite a few things on the program where people will have an opportunity to do real development at the conference. So we'll have some non-technical games, but we're also going to have some very technical activities too. So if you haven't checked out the program for Agile Games 2014, www.agilegames2014.com.
Yeah, and if you haven't been, it's just a delightful conference. I mean, there's so much about learning that goes hand in hand with play.
Well, guys, it's been a great episode. I want to give a special thanks to Llewellyn Falco for joining us tonight. Llewellyn, thank you. It's been a pleasure having you on the program.
It's very enjoyable. Thank you.
Okay, guys, that's all we have time for today. Check out thisagilelife.com for these show notes and for all of our past episodes. Thanks for listening, and keep living this Agile life.
This Agile Life is brought to you by a community of Agile developers and coaches aspiring to spread the word about this groundbreaking approach to software development. Join us at thisagilelife.com/community.